Hi, everybody. Welcome to another Chats with Chaudhry. In fact, it's a demo with Chaudhry today because I'm delighted to join by Jeff Morrow, who is from PTI, who are Packaging Technology Inspection. And Jeff is going to do a demo today on helium with cold storage. But first of all, Jeff, it's lovely to see you. How are you, first of all, my friend?
Rizwan, it's good to see you as well. I'm doing well. I hope the same for you.
Well, I'm delighted to see you. And I put some baseball jerseys out, the Mets and the Yankees, only to find out that you're actually a hockey fan. So I'll have to get a Rangers jersey for next time round.
Indeed. Indeed.
Right. Now, before we start going through the demo, would you mind giving viewers not familiar with PTI a very quick overview of PTI, but also your own role within PTI and where you're calling in from today?
Sure. PTI is a world leader in container closure integrity testing components and equipment. They have a wide variety of different sensor technologies, including now the helium leak testing technology, which I head up as product manager of the Helium Solutions division of their company, creating new concepts, building on current frames and assemblies, and assisting in sales.
Brilliant.
Right now, today, I am broadcasting to you from CS Analytical Services in Clifton, New Jersey, in the United States. They are a full-service laboratory they are involved in all aspects of many different analytical tests for the pharma industry, as well as very well in depth into this container closure integrity testing aspect of the pharma industry. One of which is our helium leak testing system here, which they were very kind to let me in today to demonstrate the cold temp aspect or the low temp aspect of our testing systems combining helium leak testing.
Brilliant. Now, before we go into the demo, and could you give us not familiar with CCI, but also about the need for testing different types of packaging at low temperatures? So first of all, why is it important to test packaging at low temperatures, and also what type of packaging would you normally test for?
Well, we want to know how a package will perform at lower test temperatures. It's easy to get a well-sealed package, or I should say relatively easy to get a well-sealed package at room temperature where things are relatively stable and we know how our materials and our package components are going to perform. Once we put them into the cold environment, many things change. Most of these, like in a vial assembly, you have an elastomeric stopper, and as we get into as we approach the glass transition temperature, that elastomer changes quite significantly, which could lead to leakage and breaches in that sealed container system. So our systems allow us to test down to roughly minus 80 centigrade. We have other systems that will allow us to go down to minus 150 centigrade. So we can ascertain what's going on with that package at those temperatures real time. So we're monitoring the package itself as far as the temperature is concerned, and then we're obtaining the helium leak rate once it's at test temperature. So right now our systems will handle glass vials. We can also do the plunger portion of a glass syringe as far as doing helium leak testing at lower temperatures.
Right. And are there other alternatives to test packaging at low temperatures, or is helium leak testing the best way of doing it?
Well, helium leak, as many of us know, is the most sensitive test method out there in terms of overall leakage. So if we can pass a helium leak test at a cold temp environment, you could be pretty well assured that moving forward, your package components have been well chosen and well selected for that particular application.
Brilliant.
As most of us are aware, the cold chain environment is very key in today's pharma market, as well as it's been in the years past, especially in our pandemic COVID-19 environment today. We had Pfizer BioNTech needing to keep their vaccines at very low temperatures for storage, and it is a very important aspect of pharmaceutical packaging and production today.
Brilliant. So I'll leave you to go ahead and do the demo then.
Okay. All right. So what we have behind me is our LT80 system, which is a liquid media based chiller, and it'll allow us to get down to roughly about a minus 80 degree temperature when we perform our test. We have a vacuum tube that's immersed into the cold medium, and then we have our sample prep portion of it here. And what we do is we'll take a pre-charged vial that has helium already in it.
Yep.
We'll affix the thermocouple to it, and then we drop this wholly down into our vacuum tube. And we will just clamp that off so we can start our vacuum draw once we reach our test temperature. And the client will have already determined what test temperature they would like to perform their studies at.
Right. Okay.
Right now, you can see we're traveling down quickly because I've got the chiller set at the maximum cooling rate, which is about minus 86.5 degrees at the current time. So right now we're already at minus 43, minus 44. And once, let's say, for example, we wanted to test at minus 50, we could then start our vacuum cycle. So now I'm evacuating that vacuum tube. And once I get into my mode where I'm actually detecting helium to the leak detector, we can ascertain whether or not we have a well-sealed package. So right now we're in the low -7 range. We just crossed over into fine test, and we've got a very, very well-sealed vial. In this case, we're at 4 to the -9, and that's millibars liters per second of helium leakage, which is very, very low. We go well beyond the mol for vials, which is generally 1 × 10 to the -6 to maintain sterility barrier to monitor that we have a well-sealed package for sterility. So generally speaking, we have a full 21 CFR Part 11 compliant software package. The site here today is doing a network upgrade, and we don't have access to the program, but we would display leak rate versus time. The program will collect all the data. We'll stop and start the detector, so it's a fully capable software package included with our helium leak test systems.
Right. I mean, I'm sure it does vary from the temperature you need to set it, but how long on average does a test take, or what's the range of time that a test would normally take?
On average, it could take upwards of 2 to 3 minutes to reach your test temperature. Some clients will actually precondition their sample, so they'll keep them in a cold environment and then just transfer them into the vacuum chamber, so there's very little lag time. And in that case, you're probably getting your data within less than a minute.
Right. And in terms of the size of the sample, is it always the same in terms of the size, or does it vary in terms of the sample size that you're testing?
Well, this chamber itself will accommodate up to about a 20R vial. We can produce larger vacuum tubes that'll give us more diameter, so we can test up to probably up to a 50R vial.
Right. Okay. And what sets the SIM solution apart from other low temperature testing technologies?
Well, we're doing it real time. We're actually monitoring the test sample real time, so we know exactly what that temperature is. We're not taking it out. We're not exposing it to cold and then taking it out and testing at room temperature. We're testing it at temperature. So anything that's going to be happening in terms of the package components at those temperatures, we'll see that in a potential difference in helium leak rate.
Brilliant. Now, I know the software is not working not available at the moment because of the network work that they're doing at the moment. But what sort of results will you, on average, be able to show with the software?
The software, as I mentioned, will show you leak rate versus time in a real time presentation. It will tabulate and collect all your data, and you'll be able to either export that data or save it to a PDF. And we have a user group on here called QA Review. They can then go in and analyze the data and review the data.
Brilliant. Now, for those people who would like to know more about this, where can they get more information?
Well, obviously, we'll go right to our website, which is PTIusa.com, or they can also check out heliumleak.com, which is the combination of Helium Leak and PTI when they acquired us back in 2020.
Fantastic. Well, look, Jeff, thank you for taking the time out to share that demo with me. It's really interesting. It's always great to see the instrumentation in operation. So thanks for sharing that. So there you go, viewers. If you'd like to know more about helium leak detection or the other technologies actually that PTI have to offer, then check out the website. I will put the link above the video. There are also lots of shows. So for example, I know they're at PACX, which is coming up. They're also at Pharma Pack, which is in Paris next week, which I'll be at as well. And there are lots more other events throughout the year as well. So you'll be able to meet the team throughout the, and also I mustn't forget they're at Interfix in 2 weeks time. So you can find them in New York if you're attending Interfix, and check out all the different technologies. I'm sure you'll be there as well then, Jeff. It's not too far away from you. So
That's correct.
Right. So, and you can meet Jeff and talk to him about helium leak detection there as well. So Jeff, thank you very much for taking time out to show me the demo, and hopefully we can do more demos in the suite as well, and see the technologies in operation. So I hope you found that interesting, viewers. As I say, check out the website, meet the team at the various shows, and as I said, if you're at Pharma Pack next week in Paris, or at PACX, or at Interfax in the next couple of weeks, to make sure you see the team there as well. And until next time, as always, stay well and stay safe. Bye-bye.